Recently, I've been working through the levels and challenges in the video game that was provided for the very first game hacking village at the DEF CON 32 conference. In the last couple of videos, we got to hack the game with Cheat Engine, patching with DNSpy, and even using Melon Loader to load mods and Unity Explorer to tweak and change whatever we would like. But in the very last video, I mentioned there might be some other secrets that we can still uncover. There's more to do and we are not yet done with this game. So in this video, we'll uncover those secrets and even make our own mod that will automatically solve all the levels and collect all the flags throughout the game. Let's get back into action here, jumping over to our computer screen. We can open up Explorer, and remember, we had set up the game hacking GG directory where we have the executable, the game itself, and this is a Unity game. Now remember, we staged it with Melon Loader in just that previous video where we got to stage all the mods and Melon Loader directory, everything that's included here in this folder. Remember, Melon Loader is an awesome mod framework for these Unity games. It'll work with mono or IL to CPP, but in this case, we're working with a mono game. And as we dive into it, look, we've got Unity Explorer already loaded and ready to work with us. You can see the Object Explorer that automatically opens the clipboard, the log, but if I actually tab over to the Scene Explorer here in the main menu, before we even load a level, look, you might be able to see one object here that's called Flag. And we can click into it, we can open it up in the inspector, and you'll note that it's kind of grayed out, but you can see it is not active. If I actually toggle this on, hey, you'll note that's green and it highlights and it brings it back to life here, but we could just toggle that off just as well. Now you might be wondering, okay, this is a flag we have not seen in the other levels, but we could take a look at some of those components like the UI or Unity Engine text here. Now scrolling down after this loads, you may very well be able to see some other interesting stuff, like the flag itself. The string, the token, the key that says, hey, we have found this Easter egg, and you'll see it right there, GHCTF for that game hacking capture the flag. It says, I guess it was not that hidden, all separated with underscores there. Okay, cutesy, just one secret flag. Let me press F7 on my keyboard to hide all the Unity Explorer options, because remember, look, that was a flag that was not in level 1, 2, 3, 4, 5, 6, all through 9 that we had showcased in the previous videos. But honestly, we could have seen, now that we're using Unity Explorer, and we'll use it more throughout this video, because it gives us so much power. Like we could, hey, look into and examine and inspect any object that we might like. And you might have noticed, actually down below, you see this scene loader option. So all the levels that we were actually jumping into for our level select are all different scenes that are represented within Unity. We've got the main menu, of course. We have level 1, level 2, level 3, but if we scroll through this, you might be able to see that level 10 that is hidden. So if I click into this and I try and load that single scene, it says, hey, how did you get here? And if I hide that Unity Explorer with F7, we can still walk around, WASD on the keyboard, jump and shift to run. Looks like we have a chest that is present here, and if I press the E key, well, it just kind of whines at me, not actually getting anything from it, and you might have actually seen that in DNSpy. If we toggle back to our desktop here, let me open up DNSpy so we could get back to some of that C# or the managed assemblies that, the DLL components that the game was made up of. Once DNSpy is running and ready for us, we could actually just go open that very same assembly C# DLL that was in the managed directory, part of the resources and the data for this game. Opening that up, we could take a look at some of the code, everything that might be present in some of the classes that are defined, and a lot of the operations and functionality for different things in the game. You might have seen chest as one of the classes that's available here. Now, I got to admit, we actually don't need to deal with much of this or do a whole lot of that reverse engineering or, hey, looking through the code to determine the logic and all, because we've got some superpowers with Unity Explorer. If I jump back to the game and press F7 on my keyboard, Unity Explorer is back open and ready for us, but rather than the Scene Explorer tab that I'm in, let me hop over to the Object Search. And this literally lets us search for any object that might be loaded in the game or in the scene. We could search for a Unity object, a singleton, or a class, or even filter it down with any sort of kind of class that we'd like, and maybe what the name contains. So what's to stop us from just simply searching for a flag? Let me go ahead and search for this, and you'll note there are a good amount of results here. But take note of the class name that's in the parentheses here, sort of grayed out with the green highlight. A couple of these are a Unity Engine game object, and those are the ones that Unity will end up working with and we could spawn in the game. You see a defense flag, you see flag medieval, and look, you probably see the hidden flag, which might tie together with our level 10 hidden level here. So if I double click on this hidden flag, we could explore all the other properties as we have previously, tweak and tune them, mess with it if we'd like, but we could also just as easily instantiate it and just spawn it into the game. So if I click this button here, you might see it, oh, the flag just popped up. And, you know, there's nothing wrong with me just walking over to it, strolling, and now just trying to go grab the flag. Once that's done, it should be in my inventory, so I can press I on my keyboard, and there it is. It says, hey, GHCTF, well played hacker, GG. Nice. Another secret we've uncovered. So what? Now we found 2 little Easter eggs, secret or hidden flags, but the original core set of levels 1 through 9, wouldn't it be really cool if we could leverage Unity Explorer and everything that we've been able to dig into previously, knowing now with sort of a forbidden strategy that we could just spawn the flag? What if we could automate the process of going level to level, each and every challenge here, spawning the flag and then collecting it so that we have a single solution to play this entire game and just do the CTF in one shot? That is what we will do next. We'll build out our own mod to do whatever we want in the game, but in this case, speedrun it, autocomplete, and collect all the flags for this CTF. And by the way, I'm sorry for like the hotel room recording. I'm out on travel. I actually am coming back from TwitchCon, but did want to get the video out for you. And with that, hey, please let me fulfill a contractual obligation and tell you about the sponsor of today's video, Vanta. Whether you're starting or scaling your company's security program, demonstrating top-notch security practices and establishing trust is more important than ever. Vanta automates compliance for SOC 2, ISO 27001, HIPAA, and more, saving you time and money, while helping you build customer trust. You can streamline security reviews by automating questionnaires and demonstrating your security posture with a customer-facing trust center, all powered by Vanta AI. Over 7,000 global companies like Atlassian, Flow Health, and Quora use Vanta to manage risk and prove security in real time. And you get a special offer of $1,000 off Vanta with my link below in the video description, jh.live/Vanta for $1,000 off. That's a discount just for our community, jh.live/Vanta for $1,000 off. Huge thanks to Vanta for sponsoring this video. Alright, so back on my desktop, I'm online at melonwiki.xyz. This is the homepage for our Melon loader and a lot of the documentation. Now you might know I really like to make sure we reference the documentation, and so you know to do that for your own learning. But check it out. We've downloaded Melon Loader already, we've got that staged, but if we wanted to end up making our own Melon and mod ourselves, what we could do is actually take a look at some of the developing Melon section here. Hopping over to the quick start and actually scrolling back up, I do want to note how this thing gets started, because they offer a super sweet convenience here, being the Visual Studio template. You will need to be working with Visual Studio, or at least would recommend that in VS, and that's a little template here for the 2022 Community Edition. You can get that downloaded if you don't have it already, but they actually have a little VSIX file that'll help stage and put together a template to get your code ready and rocking the way that you might like for your game. We could go ahead and download that from the GitHub repository. We'll just grab the VSIX file and download it here. Once we open that up, we could simply double click to install it, and it'll take just a few seconds to initialize, but then we can go ahead and click the buttons to cruise through this. Once that is done, we can go ahead and open Visual Studio. With that open, we can create a new project given some of the templates that has already prepared for us. Once we can search for a template, we'll just go ahead and search for Melon. And we'd like a Melon Loader mod. This gives us a little wizard for setting up Melon Loader mods. We can go ahead and select that, click next. We can call it whatever we like. Melon Loader mod 1 is fine. Place it wherever you would want. Go ahead and create. And this actually lets us choose the game executable. Super duper handy, because it'll help determine what kind of, bindings it might need for whatever .NET framework or what version or template and all that. You can see here in the documentation, they do note all the different things for an IL to CPP game or a mono game based on whatever version of Unity, the class, library, framework, and .NET association, all that. Look, it abstracts that away from you and keeps it super easy. So with that, we'll hop over to our game hacking GG folder, select the executable for the game, and it'll go ahead and get it all ready. Once that project is created, you can see it has set up a fine skeleton for us. It's using Melon Loader, so it has the imports already prepared, has some of the assembly information that's necessary for the class associated with our mod. In this case, we'll call that core.cs, given the file name. Whatever we want to actually call our mod, a semver or semantic versioning representation of whatever version of this mod you'd like to call it, and the author, in which case it just will default choose your username, but we can just say, hey, whatever you want there. Associating it with the game itself and whatever game developer or publisher that it might kind of put together there, but ultimately our real code kicks off in our Melon Loader namespace. And again, that's whatever you called your project with the core class that it creates that must inherit Melon mod. That's where all the good stuff is. You do want to make sure to include the colon there, but that has already set it up for us. So on the onInitialize Melon function, you can see, hey, this is actually staging just a quick, simple hello world equivalent, right? Our logger instance.message initialized. So what I would like to do is honestly just toggle this to release mode and then build it and see, okay, will it actually run on its own? Can we get our very first hello world equivalent mod running? Now this will go ahead and get started. It will build this all out and it might need to download some of the other dependencies if they don't already have it on your computer. But at the end of it, you should see, okay, one file copied, and that's kind of a convenience. It actually automatically puts your DLL into the game directory in the mods folder that you've set up with Melon Loader. Like I can hop back over to our file explorer here, mods in this directory. I had not put that there myself, copying and pasting from whatever Visual Studio had compiled it to. It just go ahead and did it for us. Super quick and convenient, in which case it might be worthwhile to try and pin this to our taskbar, so whenever we want to start the game or we make changes to our mods, we've got a quick and easy way to click into the game and go back and forth when we develop. Now when we fire this up, you should be able to see, I don't know if you caught it for just a second, be sure not to Alt-Tab or switch between windows when that Unity banner is popping up. It might just crash or hang or do weird things. So once you've got to the main menu here, if you actually go look back, our Melon Loader mod 1, whatever you called that project, will display initialized. Cool, there's our hello world little proof of concept. But let's look back at the documentation, because this will better explain, better than I can, some of the other insight and details behind all this. Note that Melon mod class, everything that it inherits from, and some of the Melon callbacks are where we can get into a little bit of the power from using our Melon mod. You already saw this onInitialize Melon method that's called after the Melon is registered. Callback will wait until Melon Loader has fully initialized, and it's safe to make any game or Unity references from and after this callback. But take a look at all the other stuff we can do here. Like there's a callback for onUpdate that's called once per frame. Maybe you could add some other functionality for, I don't know, key presses or some switches that you want to actually toggle something happening in the game. They have onFixedUpdate, they have onLateUpdate, they have onGUI for any IMGUI events, on application quit when a scene was loaded, and those might come in handy for us when a scene was loaded, because we do want to traverse through all of the levels in this case, level 1, 2, 3, all the way up to 9. Well, it'd be nice to know where we are, having that context, and we probably also want to see how do we do what we would do to switch into those scenes or move from level to level. They've got a good example here, though, of how we could use this callback, like on scene was loaded. Note that it'll take some arguments, int being the build index and string being the scene name. Okay, we saw that in Unity Explorer, right? Like level 1 - health. So those will come in handy for us. We should at least use this syntax, and that's okay for us to copy and paste for now, to play with it in Visual Studio. So let's paste in this function just to have it, and this might be a better way for us to start and anchor, okay, our mod's automatic procedure, knowing that we've actually loaded the main menu, like the game started, right? Rather than, hey, Melon Loader kicking off. That's a little bit early before we start to toggle and manipulate with what the game will do. But if we could check, given the scene name, we could say if the scene name is equal to main menu without a space and with a capital M and a capital M for main and menu. That is, I believe, case sensitive. It will get a little bit finicky there. And we saw that all in Unity Explorer, right? But now we could use this small capability that we know to just print out, okay, main menu was loaded, just to get a sanity check for us. But could we then automate jumping to level 1? And let me say, you certainly could. We could go ahead and using our using syntax, I believe it's the Unity Engine.scene management. Super cool. And with that prepared for us, down below, we could actually use the scene manager and tell it to load a scene, given a scene name. Scene manager dot load scene. In this case, we'll go to that level 1 - health, right? Don't forget your semicolon at the very end there, and maybe if we wanted to, we could add another, if statement to say if the scene name is equal to level 1 health, and you could define these all in variables or play with it if you'd like, but note that'll say loaded the first level. Just to kind of get a feel for us, kicking around with our Melon mod here and bouncing back and forth between any of the levels or scenes that we might be able to play with. With that said, I think it is worthwhile to keep an eye out for a lot of the autocomplete suggestions. Whenever you dot at the end of our scene manager class, you'll note that we could load a scene asynchronously, or get a scene by a name, or get a scene by a path, or merge scenes, move game objects to a scene. Some other properties like whether or not a scene is loaded, set an active scene. Really cool stuff that we could explore and experiment with, and it's worth just looking around online and doing our homework too. We will dig into load scene asynchronous because all that takes is an int. You might notice that int scene build index. So if we're trying to progress and traverse, loop through all the levels, hey, what's to stop us from using like a for loop, iterating with the variable I to hop through each and every level? We'll do that soon, but let me just make sure this is working the way we want. So let's Control-Shift-B, and if it gives you any hiccups, if it says, oh, the command copy just failed because, well, your game is still running and it's already got the previous DLL with the original mod that you started with. Now that you've made those changes, it can't just clobber overwrite it since it's active and running. So we will need to right click and maybe close all windows and stop the game. Then we can Control-Shift-B as a hotkey to build once again, and now it'll copy and restage that DLL and the mod for us. Open it, click it, see if we can get any of that output just to sanity check and see if we'll automatically jump to level 1. Yeah, okay. We don't even get to see the main menu. It just brought us right there. Unity Explorer is still doing its thing, but I wonder now if we could actually search for the flags, just as we've done with the object search previously. I'll type in flag, I'll hit search, and take a look. Some of our game objects here, there's one, there is that first flag, and we could instantiate that, and now we could automate that, right, with our C# code. So what's to stop us if I go grab that? Let me go see, just as kind of a gimmick here, let's go make sure if we could go collect this flag, we might have some success here. I'll hit I on my keyboard, but there's a weird thing here. The description or like the text that it would have normally displayed the flag is not showing us the flag. It's showing us this weird like base 64 encoded string, right? I could try to click around and fix my inventory, but the selector you can see is down here on the right. So I could close out of my inventory and, I don't know, try to hop around, see if we can get this to update. But I've seen this be pretty unreliable. So our inventory might get into a weird state. And it's probably worth us trying to account for that in our mod. But you might be wondering what that weird base 64 string is, right? Well, some of you that may very well have been wanting to approach this as like a capture the flag in the traditional sense, maybe you just wanted to see, okay, can I dump all the flags and like the plain text representation of them out from the game binary itself? We have our gamehackingGG.exe. What's to stop us from just running like the equivalent of strings? And I do have the sysinternal suite staged and set up here in this directory. You know what? It's probably worth opening that in command prompt, because if I were to actually try to use the sysinternal strings utility here on Windows, let me accept EULA and then look for anything in our game hacking GG executable. There's a bunch of stuff here. I'm dumping out all those plain text strings. But if I were to try and search for or use like find string on Windows, a grep equivalent over in the Linux world, I can't just as easily search for that GHCTF because they're encrypted. And you might have saw that in DNSpy just as well. Taking another look at that managed assembly, the C# kind of behind the scenes here, did you see those encryption classes alongside the decryptor class? Now this has some logic and functionality, obviously working with that base 64. I believe it ends up like actually using an XOR or a one-time pad with the flag object's quaternion, and I'm still trying to get smart on those things. And there is an approach, and I will talk about it eventually a little bit later, as to like, look, you could just write the code to reverse engineer this and then decrypt all the flags statically. But getting those assets out of the game is something you could do with like Asset Ripper or Asset Studio or UABE. A lot of other options here, but I was thinking, you know, we could do this sort of in that automated dynamic way to let the game decrypt it for you by you just hop into the flag if you spawn it with a mod. So that's the approach that we're taking, but I will show you some of the other stuff towards the end if you did want to go this route. But obviously, that is why we're seeing that weird base 64 in our inventory, and we can't as easily get all the flags out with just simple strings. We do have this small predicament though. How can we get around that problem with our inventory? That we know it just kind of jitters or glitches out when we want to start or load a level here. Unity Explorer might help us play with this, right? Because I could move around as usual. Hey, open up I on my keyboard to see, well, our inventory is still kind of glitched out. But if I were to actually go take a look at the Scene Explorer, remember that object in that class that we've seen previously, like the player inventory. Clicking on this, if we do, just like we did with the very strange hidden flag in the main menu earlier, like if we were to toggle it off and on again, even if I don't have to like toggle it on, the moment I close this out with the I key on my keyboard, if I press I again, suddenly our inventory works as it should. It's probably worthwhile turning this back on, making it an active self, but that is one way that we might still be able to bring our inventory back to life and just kind of kick it in place. So if I were to now spawn the flag, and then we could use whatever code we'll play with to actually instantiate that, get it in the level, and end up jumping to go see it, get the value out of our inventory in the description, then we could see, oh, hey, now it loads the flag value just fine. So that's some little tweak we could do. And that was just a matter of playing with it, futzing with it, and using Unity Explorer to see what weird stuff could we manipulate and toggle and see, okay, how could that help us build out our mod? So back in our code, how could we actually go grab that player inventory object and toggle it just like that? Well, what we could do is actually use the game object class that is from Unity Engine, and we could go ahead and actually find a certain kind of class. We can just simply put as a string here, player inventory, and that is what's going to end up returning, okay, the found player inventory object. And we should probably store that as our own variable. We'll call that just player inventory and capture that nice and easily. And then we could go ahead and toggle this player inventory set active being false. Just a Boolean that will autocomplete here or for us if we would like. Tab to kind of cruise through that. And we can toggle it right back on. Now that should really simply just fix our inventory for us. Next, we know that we want to be able to spawn the flag. And there were a couple of other results that came back when we would use that object search in Unity Explorer to find any class that had a flag in the name. So if we wanted sort of like a brute force approach, what's to stop us from just spawning all of them and trying to jump to all of them, no matter what they are, as long as it ends up being in our inventory, then we could search for it and find that GHCTF string. So let me build out some other function here, maybe another method that we could create, and this can be private, that's fine. It'll return an array of these game objects that it'll try to find or look for. So we could call it like find all flag objects. So inside of that, we could actually build out our list of game objects. Flag objects is a fine name. So again, we could tab to autocomplete, but we want to actually go look for all of those that are available in the current resources, right? We're not going to new array, build out our own. We'll actually use resources, which is available to us, and we could simply find objects of type all. Maybe we'll find objects of type all game object, yeah, and then try to see, okay, for every single one of those, we'll actually add to an array or our flag objects list here if it contains flag in the name. We don't need to use a whole for each loop, honestly. We could probably just use some sweet like list comprehension magic in the C# world. That can return an array given the find all flag objects, and that's probably better to call like all game objects or something, considering that's really what it is to start with. And then we'll narrow it down where we say for every single object, kind of querying, hey, does that object name contain flag as a substring? And capital F flag should work just fine for us there. Let me close out of that function. I think I actually lost my curly brace on accident, but with that, we could probably go determine all of the flag objects that are present. And if you wanted to, you could just list those all out with the logger message, sort of like that candlelight debugging print statements to make sure you're on the right track. So now we could determine all of the flag objects, and we really want to end up jumping our player to the flag that we would end up spawning, right? So we still need to be able to access our player. And I don't know if you remember when we saw it inside of Unity Explorer, that was called the POC char or car, the proof of concept character, whatever. So let's create that as a game object. We can call that our player. Make sure that is our game object find, given the string and class name. Remember, case sensitive here, I believe it was a capital P, lowercase o, capital C character. And we should also do some like error checking, hey, if that is nil or null or whatever. But look, for the sake of demonstration, I think we're okay to just keep cruising. At this point, we can actually call our find all flag objects here. So let's get that return type being flag objects for real this time, using our find all flag objects function. And then let's do a for each certain kind of game object being the flag object in all of the flag objects, plural. Let's try to spawn them. And we could do that really easily, right? We could use the Unity engine and then actually use the object little sub motion here. And that has a super sweet message to instantiate, just like we saw within Unity Explorer. You can tab to autocomplete that, but it's worthwhile to actually keep track of that object because we want to know its position so we could just jump our player over to it, right? Let's go ahead and say that is another game object type given a spawned flag. We can store that. And now we can get that spawned object's position because we'll need that, right? So look, we could honestly just kind of interrogate this. You might have remembered that transform sort of property that we saw inside of Unity Explorer. So transform actually concludes its position. Down here is one of those things we could access. There it is, position, and that includes that X, Y, and Z parameters here. All those values that are ultimately a vector3 type. So let's say, defining that as a variable for us, let's say flag position, and whoops, I'm getting into a snake case. Mixing up my naming conventions, schema, variable names, whatever. Let's actually build out a new position based off of that one that's just a little bit above it. So like gravity will take hold and then we'll land on the flag, I suppose, right? So let's do a vector3 can be new player position, actually be a new vector3. Using that all same type here, given the flag position X value, the flag position Y value, and the flag position Z value. You can see all those properties as they're cruising through, but don't forget, I do want to add just a little bit to our flag position. So like add 5. 5 is fine, right? Worth trying it out. That's the whole point. We can experiment here. And then let's set our player and their transform position to the new player position. Thank you, Visual Studio. You are reading my mind right here. Okay, so if I didn't screw anything up, we should be able to build and use this mod as, again, small proof of concept, kind of building this out piecemeal to spawn the flag, jump to it, and then we'll go from there, right? So let me Control-Shift-B, build out and compile this mod. No errors, no errors, no errors. Sweet, no errors. All right, let's go see if it even works. Spawn in the game. Get started. Brings us to level 1. Uh-oh, are we jumping to our flag? It spawned the flag, it did it. The flag is there, but we did not jump to it. Why not? What is our error message over here? Are we getting some error messages? Object reference not set to an instance of an object. On scene was loaded. Are we just moving too quick? Unfortunately, the error messages from these aren't super duper helpful because it's not like the best way to dig into your code that you're writing. We can add some debug statements just for our sake, so we can kind of see, hey, where did it go wrong? That's probably all that error handling that I said, oh, we could totally ignore, but you know what? It's not a good idea to. Taking another look, looks like it did fail to find the character. What if we did just try to wait a little bit? I am worried that like the timing is getting in the way because like, hey, the level loads, so we see the scene start, but then maybe it's just not getting the player fast enough, but it is getting the inventory. So what we could do, again, I know this is our procedural trying to automate the gameplay and tweaking and tuning things as we'd like. What we could do is actually build this into its own function. Let's make a private enumerator, that's the one, because we'll end up being able to use this as like a coroutine and something that'll allow us to actually pause or wait or sleep for a little bit without hanging up like the game thread and the DLL doing whatever it needs to do. So let's build out like a get flags where we could copy all of this, at least the capability of finding our inventory and looking for flags. That I think is good to have here. And when we do that, we will need to have some code paths actually make sure it's enumerating and like will yield an error. So like yield break if we can't find the POC player. Oh, and that actually was the inventory. Maybe I left over some typos and maybe that was having the problem earlier. Anyway, it's worthwhile us getting some waiting capability here. Oh, and forgive me, if you want to use this, you will need to have using system collections in the mix. And that'll actually have that added in a cool capability for C#. But with this, we could actually wait a little bit. Yield, I think it's new. It's yield return new wait for seconds, in which case you can just say 2 seconds, right? Then we can have a logger message saying like waiting for 2 seconds for the level to load. And then once it'll spawn the flags, we could probably jump the player to it immediately. We don't need to worry about that. But I'm curious if my typo or like my leftover copy paste screwed me over on the player inventory. But let's not forget to actually call the function. We can just do it for level 1 as our proof of concept. So we could actually use melon coroutines. That's the one. And then you can start any of these sweet ones, in which case we'll use our get flags call. That works well for us and is how we could actually sleep or wait for a couple seconds for the game to do whatever it needs to do. I'm okay with like the 2-second delay personally. As long as we still get all the flags, I think this is still a fun, cool, little approach to play with building out our own melon loader mod. So fingers crossed. We can see the game getting started once I go ahead and click the thing. We did compile, no errors just yet. Let's see. We'll dive into level 1 right away. Wait 2 seconds. Flag will spawn, and we jump to it. Heck yeah. That's pretty cool. All right, how's our inventory look? It gets the flag. Now we just need to extract it out and then do this for every single level, which will just be a for loop, right? So Unity Explorer can make this nice and easy for us because we have our player inventory object. And the components here, as we saw previously, the inventory component actually has some of the information that we could just extract out, like the contents of what is in the inventory. If I scroll through this after it loads a little bit, you can see .content being the property here. Inspect all of those 15 items or all the different slots. You can see ammo, you can see our flag 0. What if I were to try to inspect that inventory item and then see the description is where it actually hosts and includes the flag itself? GHCTF, this is the first flag, woot. So we need to extract out just about anything from our inventory that has flag in the name. Again, if we're kind of brute forcing this approach here, if the description includes GHCTF, then we've got it printed out. And then we'll traverse through the next couple of levels. Let's see if we can write that in code. So back in Visual Studio, just after we have looped through spawning all the flag objects and then jumping to them, we still have access to our player inventory. And you remember from Unity Explorer, that has the component for the inventory that we could access. So player inventory, being the game object we'll reference, we can actually get components. And the type here that we can include within the less than, greater than symbol, alligator face is waka waka. We've got inventory. However, that is actually something that is part of the More Mountains, like that game engine framework that they were using to build out this game, and their inventory engine. So we'll actually add that in as another using statement that we will have access to, because thanks to the Melon Loader and that little template in Visual Studio, it's already got a lot of that staged. So let's use that More Mountains.inventory engine, and now that won't whine at us red, angry, squiggly lines, and we'll close that out with our parentheses, and we want to capture that with its type inventory, and we can just call that object like inventory, if that's not ungodly confusing. So now from the inventory, we can check if it exists, if the inventory is equal to null, or if the inventory like content is equal to null, or if the inventory like content count being a length of those is null. Oh, and that will need to check all Boolean things. So let me do an equals 0 if like the count is 0 and there's nothing in there, in which case we can use our logger instance anyway, .msg, just a simple error message, player inventory could not be accessed or is empty. That's fine. We'll do another yield break if that is going down the wrong rabbit hole, but if it's not and we can keep cruising, then we can loop through all of the inventory items in our inventory content. Let's do a for each inventory item, and remember you saw that all in Unity Explorer as the class that associates with it. We could say the item in inventory.content. We can check if that item description actually contains, we know being the like flag placeholder or the flag standard format, GHCTF, and if it does, then we want to print that out, right? We can say logger instance dot message with a sweet little formatted string here, found flag, and then the curly braces using that $sign to denote how it's going to be formatted, our item description. And then fingers crossed, we've got a proof of concept now that at least for level 1 will automatically spawn, jump to, get the flag, and display it out for us. And we don't have to do a single thing, our mod does it for us. Let's Control-Shift-B to compile and see, hope that that works. Let the game start up. Jump to level 1, 2 seconds pass, we'll go ahead and hop over, we've got our flag. Let me hop over to my terminal and we can see, no output. Something's wrong. Are we racing against the clock here again? Should we wait just a little bit? Again, there's nothing wrong with that. I'm totally okay with, hey, let's yield, wait another 2 seconds. After we jump to them, let's do our logger instance message, waiting for 2 seconds to let the inventory update. Try that one. All right, now I don't even want to see it loading in the game. I just want to watch the terminal. We can see initialize, waiting 2 seconds, let the inventory update, found the flag. That's pretty cool. All right, now let's try and loop this through every single level. So I think the easiest way for us to do this is to note in our coroutine, like our get flags function that really handles this all, we could just do a for loop. We could do like a for int level. We'll start at 1 because that's where we know that we start with. Noting that while the level is less than, I guess there would be 10 levels, which would mean realistically 11 for an index, right? Less than or equal to 11? I guess we could try it. And then let's do level plus plus. And let's move everything and all the functionality that we had previously inside of that for loop. And at the very, very end of the for loop, let's use that scene manager. And just as I was alluding to earlier, the load scene async, where we will take our current level plus 1, right? We'll move to the next one. And found flag could probably just say like, oh, level, and include the level flag that's displayed. And we could probably clean this up, right? We don't need to display, oh, the waiting for 2 seconds, or like some of the other updates, hey, that we've jumped to a new scene. I think we could probably just like, hey, make a clean little like script, exploit script for our mod that is literally just going to go through each and every single level, spawn the flag, get it, and that's hopefully a cool way to win. So let me Control-Shift-B. I think we're okay. Let me try to run the game, and then fingers crossed, we can watch our mod automatically play it all for us, and then just churn out the flag in the command line and dump things all out for us. Jumps to it, gets it, brings us to level 2, spawns a flag. Oh, that's so cool. I think that's pretty neat. And alongside the others, it's going to do this. Are we going to die? We died. We die, but we'll still get the flag, right? Let's look back in the terminal. Yeah, look at this. Level 1 flag. Got it. Level 2 flag. Got it. Level 3 flag. Got it. 5, 6. Did we get 4? I don't know if we got 4. We didn't get level 4. If you wanted to keep brute forcing this, I feel like we've got the idea across. We could just as easily like do the inventory check after every single flag that we jump to and then wait a little bit more. Like we can move this for loop and like actually grab the inventory all inside of this in the for loop and even add another wait 2 seconds every single time. Like there's nothing wrong with that. We are, again, just playing this for the sake of seeing what could happen. And I think it's kind of been a cool success to automate playing through the game, hacking it in the cheesy forbidden strategy, right? But there's nothing wrong with that. That's kind of been the whole point. And like, look, we got to write some C# code and make a mod for this Unity game that I have never done before. So this has been a sweet learning experience for me, but it's pretty sweet to just watch it rip through the levels. And I don't know, I enjoyed this one. I hope you did too. We got level 4. You should play basketball. All right, look, with that all done, I think we have now at this point completed this game for our sake, for what we'll showcase, for everything that we'll do, unless anyone else has some other sweet secrets or any other things that we'd like to get back into this for. I think we could put this to bed and move on to something new. And hey, if I may please say, I would certainly not have been able to get anywhere near this far or learn just as much if I had not been taking a look at some of the community write-ups that other players had put together following the game hacking village at DEF CON 32. So seriously, big shout out, big thank you to all these folks that put together some sweet little info. Big shout out to Nordgaren, my editor, who's been helping me learn a whole lot more of the game hacking world. It is quite a rabbit hole. It's a whole other dimension, but I'm having a lot of fun with it and trying to get smarter. And this one is the one that gave me kind of that idea or inspiration to showcase it and extract out or loop through getting the flags. H114MX001. I'm sorry, I don't know how to say the name, but he had a super cool write-up where, look, he didn't even end up playing the game. And he adds that disclaimer, like, look, you should go through it and like do the game hacking. But he had that thought of like, look, why can't I run strings? Or why can't I just reverse engineer how this is all being protected so that it could still extract out the flags? Now, I had not very easily been able to get a static dump of the flags as well as the quaternion, or like the quaternion and what the stuff that it would do for the one-time pad and XOR. I feel like I needed the game object in some automated or dynamic way rather than just manually copying and pasting this output. That's what they actually note here. Hey, you could just copy and paste these or build them out in how you would represent the quaternion, and that is what you would be able to use and build out in a Python script. And that's what he did. He ended up putting together a Python script that would have all the input from the base 64 of the flags and as well as the data that would be coming from the quaternion. He has this sweet Python script, which is like, ooh, I wanted to be able to do that too. But I thought it would be more worthwhile to have it dynamically do that within the game and let the game decrypt it itself for you, since that's what it does in the first place. And this is all a big shout out to that Game Hacking GG Discord server. So please do jump in, join the party, and help me learn, help all of us learn, because that's what this whole thing's all about. Getting smarter, getting better, all as a community. And my goodness, it is hilariously fun to watch us automate playing through this game in a hands-off way. I know, like, yeah, we've got our time, we got our sleep, you've got our wait for a couple seconds, but I turned the sound on because it's just too much fun for me. I think it's hysterical, especially when you get to the pitfall one and we just, or the laser turret one here, and we just die. Thank you so much for watching this video. I really hope you enjoyed. I hope you learned a whole lot. I hope you got to write some sweet C# and maybe build out your own Melonloader mods just as well. And maybe you've improved this process, because I am still trying to learn. I hope you'll teach me a thing or two in the comments. Please don't hesitate. Do all those YouTube algorithm things, like, comment, subscribe. And with that, I will see you in the next video. But don't forget, please do give some love to our sponsors. They're the only reason this channel can keep doing all the sweet stuff that it might do. Thanks for watching. I'll see you in the next one.